Let's give a little bit more attention to the discriminant of the quadratic formula. So in the previous video, we learned a lot about the quadratic formula, deriving it and using it and implementing it. But the discriminant is this part of the quadratic formula. And it is the part that determines what type of answers you're going to get. Are you going to get rational answers, irrational answers, imaginary numbers, components, types like that. So let's talk about it and let's revisit this just a little bit. Now, so remember the quadratic formula goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, let's pretend for just a second, okay, that we had some numbers we've already figured out here. Let's say it was just a 2 and a 5. And then we have this part. Now, this part, after you take the square root of it, add it and subtract it to the 2 over the 5, it's going to determine whether you have something like 2 plus 4 over 5, or whether you're going to have 2 plus 4i over 5, or 2 plus the square root of 5 over 5. So let's look at this a little bit. So if b squared minus 4ac, after you clean it up, is positive, and a perfect square, like 16 or 25, something like that. Then after you take the square root of it, you're going to get an integer, right? The square root of 16 is 4, the square root of 25 is 5, and so forth. And when you add and subtract that to another integer over here and divide by an integer, you're going to get rational solutions. Now, this is where it depends on your book, it depends on your teacher, it depends on the computer program that's grading your homework. Okay, some people just want a general answer. Okay, you're going to get 2 real answers, right? And some people want a little bit more specific. They're going to be rational as opposed to irrational, right? So I'm going to try to answer all of the questions, which sort of almost makes part of it redundant, kind of a repetition, because if it's rational and not imaginary, it's going to be a real number. But okay. So if b squared minus 4ac is positive and a perfect square, you're going to get 2 real. And that may be fine for some of your books and teachers, or 2 rational, and they may call them solutions, or roots. They usually call them roots when you're graphing. Okay, let me spell that out a little bit better. Okay, if what's underneath that radical is positive and not a perfect square. So it could be things like the square root of 5 or the square root of 32 or the square root of 109. So if it's not a perfect square, you're going to get 2. They're still going to be real, but they're going to be irrational solutions, sometimes called roots. If b squared minus 4ac is equal to 0, right, then what you would have is minus b plus or minus 0 over 2a. Well, plus or minus 0 is just 0, so you would just have a singular answer. So you will obtain 1 real rational solution. And if b squared minus 4ac ends up being negative, you're going to get 2 complex solutions, sometimes called roots again. All right. So let's try a couple. And if you look back at the other video where we're talking about the quadratic formula, I talk about it a little bit while we're solving the problem. So you might go back and look at that one if you haven't seen it already. So let's try this. X squared minus 6x plus 5. All right. Now, a is 1, b is negative 6, c is 5. So b squared minus 4ac would be minus 6 squared minus 4 times a times c. So this would be 36 minus 20, which is 16. So what if you, I'm just going to do this one. Okay, so if you solve this using the quadratic formula, it would look like this. Okay, I put 4s here, but this is actually a 6. And there's a 6 down here as well. I don't know why I put 4 there. And here it goes. Sorry about that. All right. So this is 10 over 2 and 2 over 2. So this is 5 and 1. Now, so you see how you would have gotten 2 rational answers. But we don't have to work it out to decide. Okay, now if you forget, okay, let's say you're on the test and you forget and you're going, I don't remember what b squared minus 4ac has to be whatever. Work the whole thing out and see what kind of answers you get. And if you get 2 rational answers, that's what you write down. Okay, so anyway, this is a perfect square. So this is 2, all right? And you would get 2 real rational solutions. Now, some of your teachers may just want to say 2 real. Some of them may want you to go 2 rational and don't need the real. You're going to have to determine what your particular course needs you to do. All right, so A is 2, B is 8, C is 1. Now remember, it has to be equal to 0 before you can determine whether the A, B, and C are positive or negative, so don't forget that part. All right, so we're going to go B squared minus 4AC. So B is 8 squared minus 4 times A times C would be 64 minus 8, and this would be 56. Now think, if you had the square root of 56, right? 56 is not a square. Now there's a square hidden in it. It's 4 times 14, which is 2 square root of 14. So see how this tells you that you have you have an irrational number, and since it's going to be plus or minus, you have 2. So since this is not a perfect square, because remember that was our rule, if b squared minus 4ac is positive and not a perfect square, you have 2 irrational solutions that are real. Okay, so 2 real, irrational root solutions or whatever is going on. All right, now let's do x squared plus 6x plus 9. A is equal to 1, b is equal to 6, c is equal to 9. So b squared minus 4ac would be 6 squared minus 4 times 1 times c, which is 36 minus 36, which turns out to be 0. And according to our rule, it's equal to 0. You have one real rational solution, right? Which makes sense because what you would have done in the quadratic formula is you would have had minus 6 plus or minus 0 over 2, right? So plus or minus 0 doesn't do anything. You would have just had minus 3. And sometimes that's called a double root, and we talk about that in earlier videos. So this is one real, happens to be rational solution or root or whatever it is that you want to talk about. Right, one more. So what if you have x squared minus 2x plus 5? A is 1, b is negative 2, c is 5. So b squared minus 4ac would be negative 2 squared minus 4 times 1 times c, which is 5. So this is 4 minus 20. This is negative 16. And the square root of a negative 16 would be 4i, right? So you would have had whatever here and whatever there, plus or minus 4i. All right. So what you would have had is two imaginary or complex roots or solutions or whatever. Now, there, okay. All right. So a complex number is something that has a real component plus or minus an imaginary component. So it'd be something like 4 plus or minus 2i, something like that. If it's just the 2i, it's just imaginary. It's just like pure imaginary. If it's just 4, it's pure real. If it's 4 plus or minus 2i, it's complex, okay, because complex has a real, is understood to have a real and a imaginary component. Now, this one is still complex because you could think of it as 0 reals and 2 i's, or you could think of this as 4 reals and no i's. So you can make any number be complex in format. So some teachers are really sensitive about whether you're saying complex or imaginary, okay? Because imaginary, when people are talking, they understand that it could have a real number with it, but complex kind of covers it. It's kind of like proper English versus just common everyday English. So be careful and use the terminology that your teacher wants you to use. So I hope that helped. Now, what do you do with the discriminant? I've used it in other questions, not so much. I mean, they usually do ask you what the discriminant tells you about the type of solutions. But what I've actually used it for and what students use it for in other classes is they'll ask you to solve something and you go and you can look at the discriminant and say it doesn't have a rational answer, it doesn't have a real answer. Or you can talk about the answer and whether you want to pursue looking for that particular solution, okay? Because if they're asking for something in particular, like give me an integer that will do this, and you know that the discriminant is not a perfect square, you're not going to get an integer. So it's sometimes the answer is, I'm glad you asked me to do that, but it's not going to happen, okay, because it's not feasible. All right, so I can't really give you a nice firm example right now because we'd have to get into the other material first before I can show you where it's applied. So I hope this helps with the discriminant, and I'll see you in the next video. Don't forget there's practice problems in the description. And after the problem statements is the solution, and then links to the other videos. All right.